Cape Talk.
And a very good morning to you. Welcome to today. Kino Cummings and the team with you. Good morning to you, Chris.
Morning. Happy New Year. Happy 2020.
Happy New Year. And good luck for the test today.
Oh, yeah. Well, the last time we talked about sport, you know how that ended. So let's not go there.
Have you ever been a professor? Are you a professor?
Well, I've got a visiting professorship in Australia. So when I go to Australia, I'm professor. But at Cambridge, I'm just a plain old doctor. But actually, I'm doctor, because I did my medical degree, and in the middle of my medical degree, I did a PhD. And so I finished with doctor, that's no joke, ba-boom. And then about 4 years ago, Queen Mary University of London, one of the colleges in London, actually where I started my medical training, they gave me an honorary doctorate, and it was wonderful, actually. It was a really nice day. So I went down and I graduated again from the place, and I stood up to give my talk, my acceptance speech, and I said, the last time I was sitting in this hall, because the graduations were in this enormous great hall at Queen Mary, I said I was doing my second MB examinations, and I was writing all about how the brain works. So it's really nice to be back here, not doing an exam, and actually something to show for my labours. So I guess that makes me doctor.
Well, maybe we should just do it Dr. Chris Smith... PhD. I don't know. Anyway, hello. I'd like to know if I should have a medical checkup for an unusual sweat problem. I'm a 54-year-old female. Only my left armpit sweats normally, nothing on my right. I notice it when the clothes have to go for washing. I've got no health problems. I'm not on any medication. Normal mammogram, full blood count normal, except for mild non-alcoholic liver disease. And that comes from Anonymous. Any insights into that, Chris?
Yeah, this condition affects a few % of the population. It's hyperhidrosis. If this is something that's always been there, usually since late teens, then this is not something that's pathological in the sense that it's not something you've newly acquired. It's something that's intrinsic to you. The condition is hyperhidrosis, hyper meaning too much, hydrosis, water, and it doesn't have to be all over the body. It can be patchy, but it's because there is overactivity of sweat glands in a particular region. It's areas where you would naturally sweat. So people say that they get very clammy hands, so they go to shake hands with someone and they feel a bit embarrassed because their hands may be so damp. You find that your underarms can become excessively damp during the working day, so you might end up with wet patches on your shirts and clothes, for example, and also soles and feet can become very sweaty, and this can lead to foot odour and things. So it can affect your life in a very big way. There are a range of ways to tackle this, and they go from the very simple things through to more complicated things. The very simple things are, well, you just take steps in your life, perhaps improved hygiene, more regular washing to compensate. It might be that you use more antiperspirants, for example, or foot sprays in order to combat that aspect. You carry around a hanky in your pocket so that you can just wipe your hands together on that if you find that it's your hands that are chiefly affected. And then it goes up the scale. There are other ways to tackle this, but they become more intrusive, more invasive, right through to some treatments involve actually paralysing the nerves, which are the sympathetic nerves that drive the sweat glands. These are called pseudomotor nerves. And people have done studies where they put in Botox, the same stuff we use to iron out wrinkles, into the sympathetic nerve chain near the spinal cord on affected regions of the body, or just in some areas, so that the regions supplied by those bits of the sympathetic chain are less capable of sweating, and this can produce regional relief, and that's also quite effective. So I think the first thing you need to do is to say, is this something that's always been there, or is this a new thing? If it's a new thing, then there might be a health reason for this happening. For instance, there might be some underlying disease, or it might be something, for instance, the menopause. If it's an old thing that's always been there, then it's probably not got a sudden trigger, and the treatment might be just a lifestyle change.
Well, there you go. So I think the bottom line there is, go and see a doctor, have it checked out. But great insights as always from the Naked Scientist, Dr. Chris Smith. Bob in Edgemead, good morning.
Morning, Dr. Chris. A little question. I have had the habit for many, many years of having a boiled egg and a Portuguese roll for my breakfast on a Saturday morning. And a week past Saturday, I chopped the head off my hard-boiled egg to put my teaspoon in, and to my astonishment, there was a small egg inside the large egg. something about the size of a grape. And
Oops, we
dear.
seem to have lost that call, but you've got the crux of it.
Yeah. In his excitement, Bob hit the cancel button. Maybe he was getting his egg out. I've never seen this myself, but it could happen in the sense that he's seen it happen. When an egg forms, the first thing that happens is that the egg forms up inside the chicken and is invested as it comes down the oviduct inside the bird in the shell. And what it sounds like could have happened is that the nucleus that's going to form one egg then ends up being invested in the wrappings that are going to form another, and you end up with an egg inside an egg. In the same way that sometimes you can end up with twins forming, that where an egg splits apart, I suspect that basically two eggs that are trying to form eggs have merged. So I suspect that's what's happened. I've never seen it, but that would be my theory. So if anyone knows better about eggs inside eggs, then do let us know. But that would be my speculation.
Indeed. It is Brian and Turkai. Hi there, Brian. Good morning.
Hello there. Morning to both of you. My question is, I can buy from the local supermarket a good quality retractable ballpoint pen for about £6. But if I go to the optician, a pair of spectacle frames will cost me $2,000, and there's the same sort of engineering in both of them. Why the difference?
Chris?
I think that's called profit and loss, isn't it? And demand. So basically what you're paying for is the brand and the advertising. The actual amount of materials in many of these products, in these high-end products, is very, very low. But what they'll argue is enormous investment in the development of that and establishment of that brand, in road testing the brand and getting the high-end performing material up to the enormously high reputation it's got, and that all comes at a cost. And so they're passing that directly on to you. Of course, it's possible to make cheaper knockoffs, and they may not, on the other hand, have the same effect. They may not last as long, they may not work as well.
Well, it's very similar to the perfume discussion we had, where we had a company that, sells a very similar perfume. As a matter of fact, almost identically smelling perfume with the same active ingredients, or the same ingredients at least, as your top-notch brands, I won't be mentioning, but at a fraction of the cost. So you could pick it up for 140 Rand, whereas if you had to buy that other brand off the shelves, it would cost you 800-900, maybe even 1,000 Rand or more.
Yep.
And it all boiled down to marketing at the end of the day.
It does.
The cost of getting the brand out.
Yeah, and the same thing happens with medicine these days, actually, because since chemists got really good at what they do and they have fantastic equipment that can analyse a whole raft of molecules and tell you down to the atom what is in something, you can take anything in the world around us these days and you can chuck it into a mass spec machine, a nuclear magnetic resonance machine, and use a range of these analytical techniques to work out exactly what something's made of and in what proportions, which means if you make a really fantastic perfume, then you can guarantee that someone will just take that perfume, chuck it in the mass spec machine and the nuclear magnetic resonance analyzer, they'll get all the spectra out, and they could produce an identical, down to the atom level perfume, which will smell the same. But what it won't have is the brand, the legacy effect, and all the reputation that goes with that brand. And so this is what the people are fighting against. They've got to preserve the integrity of their brand. So it's very easy to knock these things off, including medicines these days. But what you're not getting is the reassurance that you're getting the real deal. And especially where medicines are concerned, there may be other things that have been done to those things that are much harder to reproduce just by knocking off chemicals. So it is actually illegal to knock these things off, because you're basically breaching a person's intellectual property. And B, there are instances where it can be unsafe, because while they may have replicated the ingredients that are in there, they may also have then said, we can get the same effect with some cheaper ingredients, and they use cheaper, nastier stuff, which also then isn't as good for you. So you have to be a little bit careful.
Yeah, I think with medicines, absolutely. And when you have the perfumes, on the other hand, I mean, some people actually buy the 1,000 Rand perfume, and when they finished and klar with that, what they do is they open it up and put the 150 Rand perfume in the bottle. So they've got the brand effect and the smell, and nobody knows. But anyway.
I had a friend who used to do that with gin, actually. He used to buy the really expensive gin and enjoy that himself. And then when he was having a party, he'd just fill the expensive gin bottle up with the cheap stuff. And by the time the party came to an end, everyone had drunk so much anyway, they didn't notice.
I can just see it happening with Rupert and Rothschild wine. And then you go and buy some plonk out of a box and fill it up, and everybody thinks you got money for good wine. Anyway, Deborah in Sun Valley, good morning to you.
Morning, Keno. I have a question relating to the sea. 2 days ago, I was coming over Boys Drive and noticed that the brownish water that got progressively browner as it headed out towards St. James spread out, and the rest of the sea was blue, but this brown water had such a sharp delineation. It was as though there was a wall around it. Somebody had just cut it. And the water wasn't murky. It didn't merge from one shade into the next. It was just a very sharp brown and then suddenly blue. And it was a curvy line. It wasn't as though it was even a straight line. And I wondered what could cause this sharpness of outline of the one water into the other.
That's an interesting one. Chris?
Morning. Yeah, this is a really interesting observation, but you can reproduce this effect in your bath. Anyone who's got a toddler who stands up and pees in the bath will be able to attest to this, because what you'll see is that often they'll produce a pool of yellow, and the pool of yellow will wash around in the bath, at least for a while, before it mixes in. And there's a number of reasons for this. And chiefly among them is that when you've got, say, urine, it's got a lot of salt dissolved in it and it's warm. And so the urine tends to be denser because there's a lot of salt and less dense because it's hot. But if it's actually if it's cooler than the bath water, which it probably is, then what will probably happen is that you'll end up with a patch of water that's yellow that will sink to the bottom of the bath and wash around there for a while before it mixes in. And it's all to do with density. So the urine, in our case, the yellow water, is more dense because it has salt dissolved in it and because it is cooler than the bath water, and therefore those water molecules have got a bit less energy, and so they tend to stick together and stay as their patch of water, and the overlying water won't mix so well. It's probably the same with your ocean water, where you've got water coming off the land, which is probably the brown stuff, or the stuff that's been up on the beach, which has picked up energy and heat from the beach, and therefore that water is warmer, and it's gone out to sea. You can see it's brown because there's probably organic material added to it from the beach, from water effluent and so on, and this is warmer and fresher, less salty, and as a result it's staying closer to the surface and it's not mixing with the colder upwelling water which is coming up from the Antarctic. So you tend to see this very clear delineation, just like your toddler who's peed in the bath.
Well, there we go. Deborah, thank you very much for the question. Bernice in Atlantis, good morning.
Good morning, Kino. Good morning, Doctor. Doctor, I'm a double cornea patient because of the allergies. Now the doctor wants to scratch one of my, the one eye is totally finished, the one cornea. And now the other one, the doctor wants to scratch it and put it in a lab to grow and put it back in. But in South Africa, they're not doing that yet. So the doctor is still lobbying, the prof is still lobbying at Grootske to do that for me. But I want to know if it's worth it or can I go on a transplant list?
So
and how long will it take for me to grow?
I'm not sure if this sort of borders on diagnosis, etc. But anyway, Chris, how would you respond to that?
Well, eye problems are very common, and your cornea is an exceptional piece of tissue. It's the piece of the front of the eye that does the heavy lifting when it comes to focusing. Does about 80 or 90% of the focusing when we look at something, because we often think the lens in the eye is the thing that helps us to see clearly, but in fact the cornea is the most important one. And if the cornea becomes injured or diseased, and this can happen for a range of reasons, it can be a traumatic reason, it can be chemical burns, it can be the immune system attacking the eye, it can be infection with things like the herpes virus, this can cause scarring. And when you take that very delicate piece of tissue and scar it, light that's trying to go through it is scattered when it goes through, and this produces blurriness, because blurriness is light that isn't being focused to a point. It's light that's falling inappropriately on the back of the retina where it shouldn't. And one way to cure this is to replace the cornea. So very successful surgery is to do a corneal transplant, and this is where you take corneal tissue from donors and you put that tissue in instead of your own tissue on the front of the eye, and this is very effective at restoring clear vision. I'm not sure about the other technique that you mentioned. I haven't done ophthalmology for a while, so I wouldn't like to advise you what's right or wrong in that case, but what I can say is A, I'm very sorry to hear about your eye problem, but B, when people have corneal transplants, they are very, very good and very effective when they work, and therefore it's worth exploring all the options rather than just going down one route and weighing up the risks and benefits, because all procedures have risks, of course.
Well, indeed. Let's go to Malcolm in the CBD. Bernice, thank you for posing that question. Malcolm, good morning.
Good morning to everyone in the studio.
Hello.
My question is to do with our perception of where we are on the earth. So technically, we in South Africa, if one looked at the entire globe, we in South Africa are sort of at the bottom. So like when we walk on the earth, we're sort of walking sideways. And those at the South Pole are sort of walking upside down. But I don't think that we have the sense that we're walking sideways or upside down. To us, everything seems like we're on the surface and upright, as it were.
Mm-hmm. And you want to know why that is. I know you're not going to make any suggestions that the Earth is flat. We know what happened to the last dude who did that.
Let's not go there.
Chris? Chris?
Morning, Malcolm. The thing to think about is, well, who says what's up and what's down? Because the only reason that we regard the North Pole as the top is because that's where most people who started making maps were based when they made maps. So, of course, they put themselves at the top and they put the Southern Hemisphere at the bottom because that made sense to them at the time. But in the grand scheme of things in the universe, well, who says that we're what's up and what's down in the universe? If you were an alien who came from the other direction, then you might conclude that actually the South Pole was the top and all these people living in the Northern Hemisphere are there upside down. So the reason we don't feel upside down or don't have this sense of being upside down if you're travelling to the opposite hemisphere is because the Earth is so enormous relative to us that as a result the curve of the Earth is so gentle that it looks like we're on a flat. And this is why people were fooled in the early days into thinking that the Earth must be flat. They realised quite promptly, actually, back thousands of years ago, that it isn't flat, of course. And Eratosthenes calculated I think it was Eratosthenes, actually was able to calculate the radius of the Earth. So he knew it was a ball in ancient Egypt doing an experiment with the sun. So people quite quickly cottoned on to the fact that it wasn't. But it is because of the size of the Earth. And if you want to know how far it is to the horizon in miles, you can do the 1, 2, 3 experiment. So you take the height of your eyes above the ground, above sea level, in feet. This is very much imperial measures, and I'm sorry to anyone who's married to the metric system, but it's 1.24 times the square root of the height of your eyes above the ground in feet will give you the distance in miles. Told you it was imperial, sorry. Distance to the horizon in miles. And you can see that it's several miles when you're 5 or 6 feet tall. And because that slope is so gentle, you can't actually experience the fact that you're moving away downwards from your current point. And because gravity works through the centre of mass of a body, the water which is smeared over the surface of the Earth is being pulled towards the centre of the Earth, and therefore the water and the land is all being pulled centrally, so it spreads itself out in a relatively even, smooth layer around the Earth, which is why it looks like everything is flat.
Well, there you go.
Today with Kino Cummies.
Only on Cape Talk.
And we're wrapping up with Chris Smith, the naked scientist, Dr. Chris Smith. One fact you didn't know is that he's got 3 of those. One of them honorary, I think how they pronounce it. But I've received a WhatsApp voice note question for you, Chris. Let's take a listen.
Hi, Kino. Happy New Year to you and your team. I just wanted to find out from the naked scientist, when someone is asleep and you look at them, it seems to be that there's a little space between the 2 eyelids. Why is there a space between the 2 eyelids when someone is asleep? And then when you close your eyes hard, you see what I'm assuming we call stars. What are those stars? Or why do we see them? Thanks, Stefan.
There's an interesting question. Chris?
I'm not quite sure about the eyes not completely closing. The bottom line is that your eyes close when you go to sleep in order to prevent the fronts of the eyes drying out, because when we go to sleep, secretions dry up. You produce much less saliva, you produce less sweat, and you produce less tear film. This is to conserve fluid because you're losing and using less fluids because you're not breathing as hard, you're not exercising as hard, and therefore you don't, and your eyes are going to be shut, so you don't need to lubricate your eyes with as many tears. So it's really to stop the front of the eye drying out, so it doesn't have to seal shut like you're sealing a jam jar or something. It should be closed enough just to reduce the evaporation from that part of the eye. And the eyeball also moves around under the eyelid when we're asleep, especially when we're dreaming during a phase of sleep called REM sleep, and that has the effect of smearing the lower level of tear film that is there around and conserving it better anyway. The question about why you see funny lights when you squeeze your eyes shut, this is an entoptic phenomenon, as in originating from within the eyeball. And it probably is due to the fact that when you screw your eyes up, your orbicularis oculi muscles, which are the rings of muscles that enable you to screw up your eyes tight, they're going to apply a force inwards on the front of the eye. This is going to be transmitted through the eyeball to the back of the eye, which is where the retina is. And at the back of the retina, the photoreceptors, which are the rods and cones that turn light into electrical signals that are sent to the brain that we call sight and vision, they poke into the choroid plexus, and this is a layer of blood vessels, a mesh of blood vessels at the back of the eye that provide the very high levels of oxygen that the retina requires. And if you apply pressure to the front of the eye, you're going to deform and distort the retina a little bit, and also you're going to adjust how the blood flows through that choroid plexus. And as a result, you're going to affect the oxygen delivery to the retina, and you're going to affect literally the tension on the retina. And both of those effects do produce aberrant electrical discharges in the retina, so you'll see flickers and flashes of lights and colours. So that's the reason why eyes don't completely close when we go to sleep, or don't need to completely close and screw up tight. But that's also the reason why when you do screw up your eyes really tight, you do see that lovely fireworks display going off inside your head.
Now, while you're saying all of this, and I'm, trying to digest everything you're saying, I see little black things floating in front of my eye, and I can actually make them go left to right, left to right. What is that? Is that just dust on my eyeball or something?
No, those are floaters, and those are extremely common, and people sometimes panic that they've got something like a worm living inside their eye. These are vestiges of the development of your eye, and they tend to be material which is floating around in your vitreous humour. There's a jelly-like substance in the back of the eye, and at the back of that vitreous humour there is a membrane that attaches to the retina. And as we get older, that pulls away. And in some people, it pulls away and produces more of these bits of material that float around, and occasionally they cross the light path of light being focused onto the fovea, the most sensitive part of the eye, and they cast a shadow. And when you see those things moving, that's the shadow drifting across your field of vision. And the reason they move is that when you move your eye around, because they're mobile, they've got some inertia. So they'll whiz off in one direction, but then they slowly crawl back again. If they're real bothersome, you can keep your eyes locked in one position and just let them settle under gravity out of your field of view, and then they'll go away. The only time you need to worry about them is if they are suddenly different. So in other words, they weren't there before and then suddenly there are lots of them, or if they look like black rain coming down, because in those cases they can be problems such as hemorrhages or detachment of the retina, or flashing lights appear. In this case, you might have a retinal hemorrhage or a detachment of your retina, and that you need to go and see someone about. But normal floaters that haven't changed, they've been there for donkey's ages, and if you look down microscopes a lot like I do, you get used to seeing them because you're pointing your head downwards and they fall under gravity straight into your field of view, and you get these things bobbing around in front of your eyes and think, what's living inside my eyeball? Just floaters. They're just a remnant of how the eye forms and evolves and works, not to be worried about.
I see 2 floaters, and that's all. That's good. That's all I need. Thank you, Chris. Listen, have a good one. Have a good weekend. Good luck for this particular test. I promise you next week, once the result is known, we won't talk about it again.
Good stuff.
Absolutely.
Have a lovely weekend, everyone.
You too, Chris. Dr. Chris Smith there, the Naked Scientist. You are listening to Today. That is right here, Today. It's the name of the show as well, by the way. I'm Kino Cummings with you.
On capetalk.co.za.
On the app.
On DSTV channel 885.
And across the city on 567 AM.
Join the conversation. You're with Cape Talk.
You're with Cape Talk.